Okay, scientific notation. It's going to be a three-part. I'll have you pause the video at various points. The first thing's something you might already know how to do. Scientific notation is to take a really small or really large number and write it in a shorter form. That's the whole point of it. Okay. Your decimal in this problem to start with is right there. Okay. Now going this way, you're always going this way. You find the first non-zero digit, it'd be 5. Your decimal has to go between the 5 and the number after it. So move it so it's between the 5 and the number after it. And as you're moving it, you count. 1, 2, 3, 4, 5, 6. Okay. So that takes me to 5.4. Times. Now whenever you move the decimal, you're actually multiplying by a power of 10. Okay. So it'd be 10, 100, 1,000, 10,000, you know, whatever. But what we do is we just put an exponent on it by how many places we moved it. 1, 2, 3, 4, 5, 6. So it'd be 6. And when you move it to the right, which was what we did, it's negative. Okay. All right, next problem. If you don't have a decimal, it's here. But you have to move it between the first non-zero digit, 6 being that first non-zero digit. Okay. So we got to go between the 6 and the number after it. 6, 7, 8, 9. So I would now have 6.7 times 10 to the power of 9. I moved it left, so when I move it left, it's a positive 9. Okay. Okay, first non-zero digit. There's a decimal. No. Right there. It's got to go between the 4 and the number after it, even if it's a 0. 1, 2, 3, 4, 5, 6, 7, 8. So I have a 4 in front, a 0, 6 behind it, times 10. And I had to move that 2, 3, 4, 5, 6, 7, 8 places to the right, so it's negative. Okay, it's like the opposite of a number line. Okay, decimals here. Sorry, that looks like crap. Okay, so find where you're going to move it. Not here, here, right there. Okay. So it's got to move between the 7 and the number after it. 2, 3, 4, 5, 6, 7, 8. So 7.008 times, you need those zeros there because there's an 8 later on, times 10. 1, 2, 3, 4, 5, 6, 7, to the 8th power. And I moved it to the right, so again it would be negative. Okay, decimal's not here, so I put it at the end to start with. And there's my first non-zero digit. I have to put it between that number and the number after it. So you got a 4 in front, a 7, 0, 9. You don't need the rest of the zeros. Times 10, and we moved it 6 places to the left. So it's positive. Okay? Left's positive, right's negative. Decimals here, it means it's at the end. So looking this way, there's my first non-zero digit. We put the decimal between that and the number after it. Okay, so 1.544 times 10. To the 10th power. That's how many places I moved it. I went left, so it's a positive 10. Okay, there's your starting decimal, so not here, here, right there. Okay. Well, if there's nothing after it, you just put it after the 7. So 1, 2, 3, 4, 5, 6, 7. So you've got your decimal, but you have a 7 in front, so that'd just be 7. Okay. 7 times 10, and we moved it 1, 2, 3, 4, 5, 7 times. You moved it to the right, so it would be a negative. Okay, then the last one you're going to do, okay, it's at the end, but we need to look this way right there. Great place for it to go. So a decimal, there'd be an 8 in front, but only zeros behind it. So I'm just going to write that as 8 times 10. to the power of 9, okay? You moved it to the left, so again it's positive, okay? All right, now on this next part, that's what you're doing on 1, 2, 3, 4, okay? Remember, the decimal always has to go between the first non-zero digit going this way and the number after it, okay? All right, now you're taking a scientific, writing it in standard form, okay? I would just use a calculator. I wouldn't waste time moving it. You know, times 10 to the positive 6. That's going to be 2,750,000. Okay? Which makes sense, because if I had to get back here, I'd have to move it to the left 6 places, positive 6 to the left. Okay? Punch it in. Okay, that's what I got there. And that only makes sense because if I had to get back to scientific, I would have to move it to the right 4 places. Since it's to the right, negative 4 makes sense. Okay, next one, 7.8 times 10 to the power of 8. So there we go. Put the commas in between. 780 million. Okay, makes sense because if I had to get back here, I'd put the decimal at the end. I'd move it between the 7 and the 8. We'd have to go 8 places left, so hence the positive. Okay, 3.2 times 10 to the negative 5th. 0.000032. Okay. All right, and that takes care of that. You might want to pause the video and do that one. Okay, part 2, what you have is 2 scientific notation numbers, and you need to multiply them, okay? It's all multiplication. So here's how I'm going to do this. I'm going to rewrite this on this problem. Multiplication is commutative. It's associative. That means you can write it in any order you want. So if I would rewrite these parentheses, since it's all multiplication, I'm going to put the 6 and the 4.8 together. Then here I'm going to put the 10 to the 4th times the 10 to the 2nd. I can rewrite that, okay? If it's all multiplication, you can rewrite it. So 6 times 4.8 is going to be 28.8. Keep your eye on that. Times, and on the 10 to the 4th times 10 to the 2nd, you put a 10 and you add the powers. 4 plus 2 is 6, okay? But that's not your answer. Your decimal has to go between the 2 and the 8. So you move it once, you moved it to the left, and you moved it once. So you add 1. So it's 2.88 times 10 to the 7th. Okay, so you have to make sure it's in proper form. Now you don't need to rewrite that. Really what I just do is I multiply the numerical bases, 0.6 times 0.2, 0.12. Times 10, and then I add the powers, negative 3 plus 5, plus negative 5. It's going to be negative 8, okay? Now, decimal must go between the 1 and the 2. It means you have to move it once, but you moved it to the right, so you're going to subtract 1, okay? That'd be negative 9. So 1.2 times 10 to the power of negative 9. So again, it's the right-left rules. You move it, add or subtract instead of positive, negative. 0.5 times 6. I got 3. If it's a single digit, we won't have to move the decimal, okay? So we can forget that. Then I add 4 plus negative 14 is negative 10, and that's great, okay? If you want to put a 0.0, that'd be fine, but the decimal is in the right place. I don't need to move it. 0.6 times 0.3. 0.18, then add the powers on your base 10. Negative 8, negative 3 is negative 11. It's a decimal in the right place. No, I should never, to be in proper scientific form, I should not have a 0 before the decimal, nor should I have 2 digits before the decimal like I did here, okay? It can only be 1 non-zero digit, so if I move it, there we go, okay? Moved it to the right. So that's a minus 1. left is a plus 1. So 1.8 times 10 to the negative 12th power. Okay. So again, make sure it's in the proper form. That's what you're going to do on that one. Now, for the second part, now you're dividing, okay? So when you're dividing, it's kind of very similar. You're going to divide the 2.6 by the 1.3, which is 2. You might want to put 2.0 times 10, and you're going to minus the powers, 14 minus 4, okay? And also in scientific notation, what you always do, you don't always get rid of the smaller one. Sometimes you do. You get rid of the one on the bottom and do the opposite. So I got rid of a 4, I'd minus 4, 10 to the 10th. That looks great. I have one non-zero digit before the decimal, so I know it's good. Okay, 4.5 divided by 9, 0.5. That's going to have to be rewritten later because you can't have just a 0 before it and be in proper form. Times 10. Get rid of the one on the bottom when doing this, and it was a negative 3, so we'd add 3. So that'd be negative 4. But the decimal's in the wrong spot. Okay, I need one non-zero digit before the decimal. If I moved it that way, I'd be good. So I moved it one place to the right. Okay, so right is a minus. So it'd be 5.0 or 5 times 10 to the negative 5th. Okay, 4.2 divided by 2.1 is 2. That'd be a 2.0, so that looks good. I have one non-zero digit before the decimal. I don't have to move it, okay? You have your 11 minus the 11, negative 3. In scientific notation, I didn't get rid of the 8 because I don't want to end up with my base 10 on the bottom. Okay, I want it on top. If I have to use a negative power, that's fine, okay? Leave it. Okay, last one, 5.1 divided by 1.7, I got 3. You can put 3.0, so you have one digit before the decimal. It's not a 0. That's good. Again, you can't have two. You got to have. It's got to be it's got to be one digit before the decimal, and it can't be a 0. Okay. If that's already the case, you're good. Times 10. Get rid of that. That was a negative 5 I just crossed out, so we're going to add 5. Okay. So negative 2 plus 5 is 3. Okay, pause the video and do those problems, and we're going to do some applications, which are not horribly hard. Okay, now here's your applications with scientific notation. A large cube is made up of many small cubes. The volume of the large cube is 7 point. By the way, here's what I want you to do. I want you to ignore the scientific notation, and let's make a couple numbers. Let's make up 20 and 5, okay? So I'm going to read it, and instead of this crap, let's say it's 20 and 5. The volume of the large cube is 20 cubic millimeters. The volume of each small cube that makes up the large cube is 5 cubic millimeters. How many small cubes make up the large cube? Well, couldn't you just divide 20 by 5? You could, so it's division, okay? But I didn't have a 20 and 5, so I take 7.506 times 10 to the 5th divided by 2.78 times 10 to the 4th, okay? It's a division. 2.7, good, I like that, okay? One non-zero digit, I'm not going to have to move it. Full positive 4 would go to the top, so it'd be 10 to the 1st, or just times 10. Okay, that's it. So it'd be 27. That's really the number 27. Okay, so it'd be 27 small cubes making up the large cube. Okay, the area of a floor is made up of many square tiles. Let's say the area of the floor is 20 square feet. The area of a tile is 4 square feet. How many tiles make up the 4? Well, again, it would be 20 divided by 4. But instead of 20 and 4, I just use these scientific notation numbers. Okay, so again, divide 8.334 by 3.324. Okay, when this happens, round to the nearest hundredth, okay? So 2.51, okay? Times 10, C of 3, subtract it, 10 to the third. That's all you do, pretty simple, okay? There are 20 acres of land. The land's made up of deer plots that occupy 4 acres of land. How many deer plots make up the land? Well, it'd be 5 if that was 20 and 4, but it's not. It's these very large numbers. And then 3.16 times 10 to the third. This is pretty easy. You may have even done something like it in another class. So that'd be 2.29, okay, times 10 to the first. So it'd be about 22.9, okay. This would be 2,510 actually on that one. Okay, now I put another scientific notation application. A light year is a distance light travels in 1 year, okay. Light travels it never really ends, okay, it travels. And I'm not Joe and I, the science guy here, but it travels 5.9 times 10 to the 12th miles per light year. How many miles does a light travel in 3 months, okay? So you can find the distance light traveled if you took that number in scientific notation and multiplied by the years, okay? That would be the total distance traveled because it says per year. So, well, you're like, well, I don't have years. I got 3 months. Well, you can use 3 for the years. You just got to put a 12 under it because there's 12 months in a year. Okay? That's all you have to do. So let's take 5.9 times 3/12. And yes, I'm well aware that that's 1/4. Okay? Divide by 3, 1/4. But you can use 3/12 if you want. 1.475, decimals in a good spot, don't have to move it. We got the one digit before it, times 10 to the power of 12. Okay? This is my only base 10, so it's just 10 to the 12. Okay, a light year is a distance light travels in a year. Because the speed of light's not going to change, okay? That's going to be your number that you roll with every time. And you can find the total distance traveled if you take it times the years. Well, we have the years this time. It's 2 full years, so I don't need a fraction. I take 5.9 times 2. 11.8, that decimal's not in a good spot, so we will fix that. Remember, you have 2 digits now before the decimal. Neither one of them is a 0, okay? So it's not going to work. So you better move it. So there's one digit, okay? You had to move it to the left. When you move it to the left, you add how many places you moved, which is 1. So it's 1.18 times 10 to the 13th power. That's an astronomically high answer, okay? Because to find the number that actually is, yeah, see, it's such a big number, my calculator won't even hold it. Okay, a light year's distance, light travels in 1 year. Light travels 5.9 times 10 to the 12th, yada, yada, yada. How many miles do we travel in 90 days? Times the years. Now, you're like, well, that's days. Well, I can use 90 as long as I put it over how many days are in a year, because that's how a fraction works. It's 90 over 365. Okay. So I take 5.9 times the fraction, 1.45, that's it, the decimal's in a great spot, times 10 to the power of 12, okay?